Next, we're going to review how to use trigonometric ratios to solve for an angle. Example 1. Determine the indicated angle. When solving problems, the first thing we should do is label our diagram, state an equation, and then solve. So let's start by labeling. So let's call this side A, side B, and side C. So what we know is side C, and we also know side A. And then the next thing we need to do is identify what sides they are relative to our angle of focus. Since our angle of focus is angle A, then side C we know is our hypotenuse because it's across our 90-degree angle, and side A is opposite angle A. So we need a ratio that has opposite and hypotenuse in it. And if we look at our list of ratios, we know that sine of A is equal to the opposite over the hypotenuse. So A over C. Now that we've stated our equation, we need to substitute in our values and solve. So for this one, we get sine of A is equal to 15.7 over 25.2. What we need to do now is get rid of the sine that's attached to the A. And to do that, we have to use what's called the inverse of sine. Or on your calculator, we just call that sine minus 1. The opposite operation of a ratio is to take the sine minus 1 to get an angle. So to get rid of the sine that's attached to the A, we have to use sine minus 1. So on your calculators, you'll find your sine minus 1 button, or your inverse sine button. Include a bracket if it doesn't already include one. Then 15.7 divided by 25.2. Close the bracket and hit enter. And we should get that angle A is equal to approximately 38.5 degrees. So again, on your calculator, for most of yours, you might have to have a second function button, or a second button, or a shift button you might have to hit first, depending on your calculator. Then you're going to find your sine button, has a little sine minus 1 probably sitting right above it. Then you might need a bracket. If your sine doesn't include a bracket, you'll use your bracket key. You'll type in 15.7. Use your divided by key, 25.2, and then hit your equals key, or enter, depending on your calculator. So again, without seeing your calculator, you'll have to find this button first in order to use your sine minus 1 or your inverse sine feature on your calculator. So let's keep on trying this. So angle of focus is right here, it's theta. And let's label this A, B, and C. We have side B, we have side A this time. So since our angle of focus is A, here is our opposite to angle A. 53 feet this time is adjacent to angle A because it's right beside it. So adjacent to angle A. And we know it's adjacent because this is our hypotenuse. The ratio we're going to use this time is tan. And we have tan of A is equal to opposite over adjacent. So A over B, the two sides that we know. Subbing in our values, we get the tan of theta this time. If you want to keep it A, you can also leave it as A. So let's keep it as A. And we have 41 over 53. Again, we need to undo that tan or get rid of that tan that's attached to the A. So to do that, we take the tan minus 1, and that's 41 over 53, Typing that into our calculator, we get that angle A is approximately equal to 37.77 degrees. And again, to get this fancy button tan with a -1, you're going to have to hit your shift or your second button, and then your tan button will give you a tan with a little -1 attached to it. Let's look at the next example. So the next one, it says solve the triangle. Solving the triangle means determine all the side lengths and all the angle measures. So first let's label this triangle. So A, B, and C. This time we want to find side C. We already know side A, we already know side B, and we want to find, let's say, angle A and angle B. So there's three things we need to find. Two angles, one side length. And for this one, we can start with any of them. So let's say we choose to start with side C. The nice part about side C is, since we have a right triangle, we can use Pythagorean's theorem. And we know that that is c squared equals a squared plus b squared based upon our diagram. We have that a is 7 and b is 24. So we get that c squared is equal to 625. In order to find c, so we're going to square root this, and we get that c is exactly equal to 25 units. So now we have c for our triangle. It is 25. Next, we can pick an angle. So let's say we pick angle A. We're going to focus on angle A. If we focus in on angle A, then this side is opposite angle A, and the other known side is adjacent angle A, since C is our hypotenuse. We could use the hypotenuse as well, but just as a tip, if you made a mistake finding side C, that would then give you an error when you look for angle A or angle B. All right, so let's go and look for angle A. So if we want to look for angle A, we're going to use the tan ratio, the tan of A, because we have the opposite and the adjacent side. So remember, tan of A is opposite over adjacent, which in our example is A over B. We put in our numbers, so we get tan of A, or theta if we want, is 7 over 24. And to find angle A, we're going to take the tan inverse. Remember, we have to get rid of that tan from the A, so we do the tan inverse of 7 over 24. Again, we only use the tan inverse or the sine inverse or the cos inverse if we are looking for an angle. So we get that angle A is approximately equal to 16.3 degrees. Let's put that in our diagram. So we get 16.3 degrees, and all we have left is angle B. So there's two ways we can find angle B. So for angle B, we can use the 180 rule. In a triangle, all the angles add up to 180. So we did 180 minus the 16.3 degrees plus the 90 degrees we already know. We can show that angle B is equal to approximately 73.7 degrees. So here we get 73.7 degrees. Now, a second way to find that is to again use our tan ratio. And if we do that method, let's say we're focused on angle B this time, we can call this the side opposite angle B. This is the side that's adjacent angle B. And using our tan ratio, the tan of angle B, let's call this our verify step, is equal to the opposite side to B is B over A. So we get tan of B is equal to 24 over 7. And now if we want to find angle B, that's the tan minus 1 of 24 over 7. And you see we get 73.7. Same as what we got by using the 180 rule. All right, next part. In order to complete the next question, in order to understand the next question, we're going to look at two new definitions. The definitions are angle of elevation versus angle of depression. So the angle of elevation is the angle between the horizontal, so here's our horizontal, and the line of sight when looking up at an object. So there's looking up at an object. So the angle going from the horizontal and looking upwards. The angle of depression is the angle between the horizontal and the line of sight looking downwards. So that angle would be this one right here. So here's an example using some of that terminology. So Jenny and Nathan want to determine the height of the Pickering wind turbine. Jenny, shown here, stands 60 feet from the base of the turbine, and she measures the angle of elevation to the top to be 81 degrees. That's right there. On the other side of the turbine, Nathan measures the angle of elevation to be 76 degrees. And it tells you that they hold the clinometers 4.8 feet off the ground. And all that is the measuring device used to find the angle of elevation or depression to an object or structure. So part A, what is the height of the wind turbine? Notice in this diagram we have two triangles. So I'm going to take apart the first triangle. That's the one Jenny is standing beside, because it has more information than the one Nathan is beside. So the wind turbine is this H here, is the height of this triangle. Jenny measures the angle of elevation to be 81. She's standing 60 feet away. So her angle of focus is 81 degrees. She wants to find the side opposite the 81 degrees. So let's label this triangle. Let's call it A, B, and C. So this is opposite angle A. And she knows 60, which is adjacent to angle A. Adjacent angle A. So we need a ratio that has opposite and adjacent attached to it. And that ratio would be your tan ratio. So tan of A is equal to opposite, which is side A, over side B. Remember, this is side B, this is side A. Subbing in our values, we get the tan of 81 is equal to H over 60. Since the right side says H divided by 60, the opposite operation is to multiply both sides by 60, so we can get H by itself. And we end up with H is equal to 60 tan 81. And therefore, we get that the height of that triangle is approximately equal to 378.8 feet. That's H. But that does not answer our question. That's not the height of the wind turbine, because we have to include the fact that the measuring device they used was 4.8 feet, off the ground. So therefore, the wind turbine is, we're going to take 378.8, we're going to add 4.8 to that, and that's going to give us 383.6 feet tall. So the wind turbine is 383.6 feet tall. Remember, we just took and added 4.8 feet to our calculation. All right, let's answer part B now. So part B wants to know, how far away from the base is Nathan? So here's the base. They want to know this distance here. So let's draw out his triangle. So here's his triangle. He has 76 degrees as his angle of elevation. So we have Q as the base here. And we now are going to take the H from our previous result, 378.8, and use that for the height of his triangle. So here's our angle of focus again. Let's label our diagram. So his will be A, B, and C. So here's our side B, here's our side A. We also note that this is opposite our angle of focus, so opposite angle A, and this time this is adjacent our angle A. So once again, we're going to need the tan ratio because the tan ratio has opposite and adjacent in it. So tan of A is equal to A over B. Let's sub in our values. Tan of 76 is equal to 378.8 over B, or in this case, Q. Remember, this is the case when we have the variable in the denominator, so we're going to flip this equation. So we're going to flip both sides of this equation. So we get 1 over tan of 76 is equal to Q over 378.8. To get Q by itself, we're going to multiply by 378.8 on both sides. And we end up with Q is equal to 378.8 over tan of 76. So remember, these cancel each other out to give us 1. The rest is calculator work. And we end up with Q is approximately 94.4 feet. So therefore, Nathan is 94.4 feet from the turbine. All right. So here are some questions you should try. They're from your textbook. And then I've thrown in an extra question here. I want you to solve the following triangle. And then once you've solved the triangle, I want you to determine the area of this triangle and its perimeter.